Question 1. In the context of operating ground support equipment, GSE, for preconditioning an aircraft at a remote stand in Phoenix during peak summer heat, technician Mr. Vasquez noticed the cabin temperature was not decreasing despite continuous operation of the preconditioned air PCA unit. He also detected an unusual vibration and a rising pressure reading on the discharge side. What should Mr. Vasquez do next? A. Continue operating the unit as vibration is normal in high ambient conditions. B. Shut down the PCA unit and inspect for a clogged condenser or fan obstruction. C. Adjust the refrigerant charge to compensate for heat load. D. Open the bypass damper to relieve pressure temporarily. Answer. Correct answer. B. Shut down the PCA unit and inspect for a clogged condenser or fan obstruction. Explanation. Normally high discharge pressure and vibration indicate airflow obstruction or heat exchange inefficiency, common in clogged condenser coils or blocked fans. Continuing operation may lead to compressor failure. FIC 43.13, 1 and OSHA 1910.212 machine guarding, EMP, preventive actions in the presence of abnormal vibrations and thermal readings. Refrigerant should never be added unless verified by superheater cooling measurements. Opening bypass dampers is a temporary solution and not a fix. Safety and diagnostics must come first in aviation HVAC applications. Question 2. The fundamental question is, what is the impact of pressure differential across cabin bulkheads on HVAC system design in large commercial aircraft? A. It requires the use of reinforced ducting materials and stage pressure regulators. B. It has no impact as the HVAC system is isolated from cabin structure. C. It only affects avionics bays, not cabin areas. D. It reduces cooling capacity due to reverse airflow into pressurized zones. Answer. Correct answer. A. It requires the use of reinforced ducting materials and staged pressure regulators. Explanation. Aircraft HVAC systems must account for cabin pressurization. According to FAR Part 25.841 and ASHRAE aviation-specific guidelines, differential pressures require specially rated ducting to prevent collapse or rupture and pressure regulators to maintain consistent flow across pressurized zones. Incorrect assumptions about system isolation or limited effect to avionics can lead to design and operational failures, especially during rapid altitude changes. Question 3. From the perspective of materials science, technician Riley is replacing a section of ducting in a narrow-body aircraft. The replacement material is aluminum alloy, but she notices the original duct used, a composite laminate. What should be her primary consideration before proceeding? A. Aluminum is always acceptable due to its durability and corrosion resistance. B. Confirm with engineering drawings and fire-proofed materials list before substitution. C. Proceed with replacement but ensure the duct is properly insulated. D. Only replace with stainless steel for higher strength. Answer. Correct answer. B. Confirm with engineering drawings and fire-proofed materials list before substitution. Explanation. Substituting materials in aircraft requires fire-proofed documentation. AC 43.13, 1 and FAR Form 337 guidelines strictly prohibit unauthorized changes due to differences in weight, stress tolerance, and thermal conductivity. Composite laminates are often used for weight savings and vibration resistance. Aluminum, though durable, may not meet certification or performance requirements. Only FOSS-certified materials listed in the IC Illustrated Parts Catalog should be used. Question 4. Illustrated by Mr. Jenkins' attempt to diagnose an intermittent failure in an aircraft's vapor cycle system. He observed that the system operates normally on the ground but fails at cruising altitude. He suspects sensor is malfunctioning. Which sensor is most likely contributing to the failure? A. Ambient temperature sensor. B. Cabin humidity sensor. C. Pressure altitude transducer. D. Return air thermistor. Answer. Correct answer. C. Pressure altitude transducer. Explanation. Aircraft vapor cycle systems often interface with sensors that adjust operation based on altitude due to changes in ambient pressure. A faulty pressure altitude transducer can cause systems to miscalculate load conditions, leading to shutdowns or performance drops. FARC guidance in AC 251309 1A and RTA 160 specify environmental qualifications for such components. Humidity or return air sensors do not typically impact altitude-based performance directly. Question 5. Through careful analysis of airflow dynamics in aircraft ducting, why is laminar airflow preferred over turbulent airflow in long duct runs leading to cabin diffusers? A. Turbulent flow increases system pressure and reduces overall cooling efficiency. B. Laminar flow reduces noise, but increases energy usage. C. Turbulent flow is required for proper heat exchange in insulated ducts. D. Laminar airflow is less responsive to sensor adjustments and should be avoided. Answer. Correct answer A. Turbulent flow increases system pressure and reduces overall cooling efficiency. Explanation. Laminar airflow maintains a steady velocity profile with low friction losses, which is critical in long duct runs to reduce energy consumption and pressure drops. ASHRAE fundamentals and FAR-X design practices support the use of smooth duct transitions and appropriate duct sizing to preserve laminar flow. Turbulent flow creates inefficiencies, noise, and unpredictable distribution patterns, especially problematic in tightly controlled cabin environments. Question 6. While performing preventive maintenance on an aircraft's avionics cooling system, technician Is Delgado notes 15% increase in fan motor current and slight drop in airflow to the mission-critical equipment bay. The filters were replaced recently and the ducting is clear. What is the most likely root cause? A. Incorrect phase voltage supply from the aircraft power distribution panel. B. Clogged evaporator coil in the vapor cycle cooling loop. C. Damaged thermistor in the bay's temperature sensor array. D. Internal bearing failure in the fan motor. Answer. Correct answer D. Internal bearing failure in the fan motor. Explanation. Increased motor current and reduced airflow are classic symptoms of mechanical resistance, such as bearing wear. FI C43.13 and UP emphasized checking electromechanical components for wear signs. Voltage imbalance would present differently, and thermistor faults would affect temperature readings, not airflow. Coil clogging would affect cooling, not airflow directly. Avionics cooling reliability is critical. Any degradation must be resolved quickly. Question 7. With the advent of modern diagnostic tools, technician Mr. Arman uses an electronic gauge set to analyze a vapor cycle system. He notes that superheat is extremely high while subcooling is minimal. What does this indicate? A. The system is overcharged with refrigerant. B. There is a restriction before the expansion valve. C. The evaporator coil is saturated with moisture. D. The compressor is short cycling. Answer. Correct answer B. There is a restriction before the expansion valve. Explanation. High superheat and low subcooling typically indicate a refrigerant starvation issue, often caused by restrictions before or at the TSV thermostatic expansion valve. This could be due to contamination or blocked filter dryer. According to EPA Section 608 and FAR maintenance practices, verifying system pressures and temperatures against expected values is key to diagnosing flow issues. Overcharge would cause low superheat. Moisture saturation would impact coil performance, not pressure conditions directly. Question 8. During a high-altitude test flight, NASA observes that the cabin pressurization control system begins to cycle erratically, causing minor pressure fluctuations and passenger discomfort. After landing, he is tasked with investigating what component should he prioritize for inspection. A. Outflow valve actuator and its feedback loop. B. Cabin insulation integrity. C. Inlet air duct heater control relay. D. Compressor clutch engagement sensor. Answer. Correct answer A. Outflow valve actuator and its feedback loop. Explanation. Erratic cabin pressure changes often result from feedback control failures in the outflow valve system. The actuator's inability to position correctly or poor signal from the position sensor can cause inconsistent pressure regulation. FAR AC2520 and OTA Chapter 21 highlight the role of active feedback loops in cabin pressure management. The heater relay. Clutch sensor relate to temperature, not pressure. Insulation affects temperature, not pressure regulation. Question 9. The relationship between weight constraints and cooling capacity is crucial in aviation HVAC system design. Why are air cycle machines ACMs preferred over vapor cycle systems in many large aircraft? A. ACMs use no refrigerant and rely on engine bleed air, reducing system weight and complexity. B. Vapor cycle systems offer higher efficiency but are too powerful for large aircraft. C. ACMs generate high humidity, which is beneficial in high altitude conditions. D. Vapor systems are banned by the FAR in aircraft over 50,000 pounds. Answer. Correct answer. ACMs use no refrigerant and rely on engine bleed air, reducing system weight and complexity. Explanation. ACMs exploit the reverse Brayton cycle and engine bleed air for cooling, avoiding heavy compressors and refrigerant loops. This suits the weight and reliability requirements of large aircraft. FI C12089 and aircraft design principles emphasize system simplicity and redundancy. Vapor systems are not banned but used smaller or specialized aircraft, e.g. business jets where bleed air is limited. Question 10. In light of recent developments, why must refrigerant leak detection be performed using electronic sensors rather than soap bubbles in aircraft applications? A. Electronic sensors detect temperature variations caused by leaks. B. FAR regulations prohibit any liquid-based leak testing. C. Soap bubbles cannot detect microleaks under pressurized enclosed panels. D. Electronic sensors are more cost-effective in the long run. Answer. Correct answer. C. Soap bubbles cannot detect microleaks under pressurized enclosed panels. Explanation. Leak detection in aviation must be precise due to confined spaces and safety requirements. FI C43.13 TORB Section 218 recommends electronic detectors infrared ultrasonic capable of finding microleaks that could escape detection by visual methods. Additionally, soap can corrode certain or leave residues. High altitude performance depends on sealed systems, making early detection essential. Question 11. The effectiveness of high-altitude HVAC systems depends heavily on understanding how atmospheric pressure affects refrigerant behavior. Technician Mr. Bowen is tasked with troubleshooting a drop in system efficiency at cruising altitude. He notes the compressor seems to be working harder than normal. Which principle best explains this condition? A. Refrigerant charge expands excessively due to high ambient pressure. B. Reduced atmospheric pressure increases suction line pressure, overloading the compressor. C. Low ambient pressure reduces condenser efficiency, making it harder to reject heat. D. Low altitude results in excessive evaporator loading. Answer. Correct answer. C. Low ambient pressure reduces condenser efficiency, making it harder to reject heat. Explanation. At high altitude, ambient pressure drops, which reduces the temperature differential required for the condenser to reject heat efficiently. FAR X design guides emphasize the challenges of condenser function at altitude. The compressor must work harder to maintain pressure difference. This is a direct application of thermodynamic principles in environments. Question 12. During the process of routine avionics bay inspection, Tamura observes condensation forming near the air discharge port of the cooling duct. The system otherwise functions normally. What is the most probable cause of this condensation? A. Incorrect routing of air ducts causing thermal imbalance. B. Elevated humidity within the equipment bay due to evaporator inefficiency. C. The use of uninsulated ducting in a low temperature airstream. D. Overcharged refrigerant causing temperature overshoot. Answer. Correct answer. C. The use of uninsulated ducting in a low temperature air stream. Explanation. Cold air moving through metal ducts in humid environments leads to condensation on the outer surface if not insulated. FI C25.1309 and ASHRAE standards require proper insulation for ducts delivering chilled air. This prevents moisture from damaging avionics and ensures temperature stability. Refrigerant chart. Evaporator performance wouldn't cause this surface condensation alone. Question 13. While inspecting an older military cargo aircraft, Mr. Daniels identifies that the air cycle machine ACM is producing cool air but at an abnormally low flow rate. Filter inspections reveal no blockages and sensors are reporting correct data. What should be Mr. Daniels' next step? A. Replace the cabin temperature controller. B. Inspect the turbine or compressor wheel for erosion or damage. C. Add refrigerant to compensate for reduced flow. D. Flush the bleed air line to remove moisture. Answer. Correct answer. B. Inspect the turbine or compressor wheel for erosion or damage. Explanation. Erosion or imbalance in the EACM rotating components, especially the turbine or compressor wheel, can drastically reduce airflow despite correct temperature output. FAR maintenance procedures for X highlight performance losses due to mechanical degradation in ACMs. Refrigerant isn't involved in ACMs and temperature controllers do not affect flow volume. Question 14. Given the circumstances where cabin sensors report inconsistent temperature zones across different aircraft sections, technician is to Kruger suspects a failure in the temperature regulation logic. What component is most likely at fault? A. The zone control valve. B. The cabin humidistat. C. The air temperature selector panel. D. The zone temperature controller ET. Answer. Correct answer. D. The zone temperature controller ETC. Explanation. The VTC regulates the blending of hot and cold air based on sensor feedback. 5 and OTA 21 protocols show that inconsistencies in temperature zones often stem from ETC malfunctions or programming errors. Humidistats regulate moisture, not temperature. Zone valves respond to ETC signals, but are rarely the root issue without erratic ETC behavior. Question 15. Throughout the course of servicing the refrigerant recovery process on an aircraft, Mr. Omar observes bubbles in the sight glass even after the system is supposedly fully recovered. What should he interpret from this? A. The system is still under high pressure and should be left to cool. B. Moisture contamination has formed microbubbles in the oil separator. C. A vacuum leak or incomplete recovery is allowing air into the system. D. It is a normal visual artifact and can be ignored. Answer. Correct answer. C. A vacuum leak or incomplete recovery is allowing air into the system. Explanation. Persistent bubbles in the sight glass during recovery typically point to air ingress from a leak or incomplete evacuation. According to APA 608 and FAR guidelines, ensuring full recovery is critical to system integrity. Moisture bubbles occur during operation, not recovery. Ignoring it violates safe servicing protocols and could lead cross-contamination or non-compliance. Question 16. In terms of redundancy in critical X systems on commercial aircraft, what best describes the false position on design standards for failure scenarios? A. X must shut down completely upon first fault to prevent cascading failure. B. Backup system must be available but does not need to activate automatically. C. Systems must include automatic switchover capabilities and maintain safe cabin conditions. D. Redundancy is only required on aircraft with more than 100 passengers. Answer. Correct answer. C. Systems must include automatic switchover capabilities and maintain safe cabin conditions. Explanation. FAR Part 25.1309 and AC2149 mandate that critical systems including X maintain functionality under single-point failure. Automatic redundancy ensures cabin pressure, temperature, and ventilation remain within limits to preserve safety. Switchover must not rely on pilot intervention alone. Passenger capacity doesn't change safety design criteria for pressurized aircraft. Question 17. Jennings is performing performance testing on an avionics bay vapor cycle unit. The compressor shows a consistent duty cycle, but the air temperature remains above acceptable limits. She finds subcooling is within range, but superheat is excessively low. What does this suggest? A. The system is undercharged. B. The expansion valve is stuck open. C. The evaporator is oversized for the application. D. The sensor is installed in the wrong location. Answer. Correct answer. B. The expansion valve is stuck open. Explanation. Low superheat with normal subcooling typically indicates the evaporator is flooded, often due to stuck open TSV. This allows too much refrigerant to enter, reducing its ability to absorb heat effectively. FAR X troubleshooting and EPA Section 608 service manuals advise checking valve operation when temperature control is lost, but pressures seem acceptable. Question 18. With respect to component replacement standards, technician ISTRA-NG is replacing a failed temperature sensor in an aircraft's X. The only available replacement has the same electrical resistance profile but different response time curve. What is the proper course of action? A. Replace it immediately since electrical specs match. B. Only install it if approved by the manufacturer's service bulletin. C. Install and calibrate it manually during testing. D. Use it temporarily until the correct part arrives. Answer. Correct answer B. Only install it if approved by the manufacturer's service bulletin. Explanation. Per FIC 43.131 and the aircraft maintenance manual component substitution is only allowed if covered by manufacturer approval. Matching electrical resistance alone doesn't guarantee system integrity. Response curves affect feedback to controllers, possibly leading to over-under correction in critical X systems. Unauthorized substitute may violate airworthiness requirements. Question 19. The core principles of thermodynamics apply directly to air cycle machines, ACMs. Why is reheating the air in the final stage of EM processing necessary before delivering to the cabin? A. It reduces humidity to comfortable levels. B. Prevents condensation forming on diffusers and ducting. C. It improves oxygen content in conditioned air. D. Avoids passenger discomfort from extremely cold supply air. Answer. Correct answer. D. Avoids passenger discomfort from extremely cold supply air. Explanation. ACMs cool air to near freezing using expansion and compression. Reheating, usually with heat exchangers or trim air, ensures delivery temperature is tolerable. FAR-X design guidance requires cabin air to stay within comfortable ranges approx. 1827 deg. Extremely cold air could cause discomfort or even localized freezing. Humidity affected but not the main driver here. Question 20. Based on the information collected from a system diagnostic, Rog determines that one zone in the aircraft is cooling rapidly while others remain warm. Ducting is intact and the temperature sensor reads accurately. What is the likely fault? A. Malfunctioning modulating air mixing valve. B. Faulty zone humidity controller. C. Obstructed return air path from other zones. D. Low refrigerant charge in the system. Answer. Correct answer A. Malfunctioning modulating air mixing valve. Explanation. When one zone overcools while others do not and sensors dampers are functional, the issue is often with the air mixing valve not regulating blend temperature properly. FAR Chapter 21 outlines how modulating valves control delivery temperature based on demand. A humidity controller wouldn't impact temperature and refrigerant issue would affect all zones equally. Question 21. While troubleshooting an X failure on a business jet, Keaton notes the cabin is pressurizing normally, but there is a strong chemical odor near the flight deck. Inspection of the vapor cycle cooling unit shows no active alarms. What should be his immediate concern? A. Check for ozone buildup from high altitude pressurization. B. Inspect the evaporator coil for chemical fouling. C. Shut down the system and test for refrigerant leaks near the cockpit. D. Run a carbon monoxide test on the airport. Answer. Correct answer. C. Shut down the system and test for refrigerant leaks near the cockpit. Explanation. Chemical odors near the cockpit, especially under normal pressurization, may indicate refrigerant leaks. FI C43.131 and EPA Section 608 require immediate system shutdown and leak testing, especially in confined areas. Refrigerants can displace oxygen or cause neurological effects in high concentrations. Ozone or CO would present differently, and the evaporator coil is a secondary suspect unless fouling is confirmed. Question 22. To better understand the performance characteristics of refrigerants at high altitude, why are some modern aircraft vapor cycle systems transitioning from R134 to R1234F? R1234F offers higher pressure operation, which improves high altitude performance. B. R1234F is more environmentally compliant with LDW ratings. R134 causes evaporator freezing during descent. D. R1234F is required under new FAR fire suppression regulations. Answer. Correct answer B. R1234F is more environmentally compliant with LDW ratings. Explanation. R1234F is favored due to its ultra-low global warming potential debut and compliance with the EF gas and EPA SNAP rules. FAR accepts it for aircraft use when fire suppression tests are passed. It doesn't significantly alter pressure characteristics compared to R134A. Fire suppression regulations do not mandate R34F but rather address containment and risk. Question 23. The impact of improper airflow distribution in an aircraft can manifest as localized thermal discomfort. Technician Keller is troubleshooting uneven cooling in the galley. Sensors and temperature settings are correct. What system elements should be prioritized? A. The zone temperature controller for the galley. B. The insulation rating of the galley ductwork. C. The positioning or blockage of discharge diffusers. D. The refrigerant charge level in the X. Answer. Correct answer. C. The positioning or blockage of discharge diffusers. Explanation. Improper diffuser alignment or blockage can cause localized comfort issues without affecting temperature readings. FAR X guidelines and ASHRAE standards stress that diffuser performance affects airthrow and mixing. ETCS may work correctly, but delivery issues must be addressed physically at the outlet. Insulation and charge affect system-wide behavior, not just the galley. Question 24. While servicing an older cargo aircraft, ISTA Rosario is required to replace a relay that controls the compressor clutch. The replacement relay meets voltage and current specs but is not listed in the IC Illustrated Parts Catalog. What is the most compliant next step? A. Replace the relay and document it in the maintenance log. B. Proceed only if FAR field approval is issued. C. Use the part temporarily until the approved relay is available. D. Perform resistance tests to verify compatibility and proceed. Answer. Correct answer. B. Proceed only if FAR field approval is issued. Explanation. Parts not listed in the IC or manufacturer's authorized data must undergo FAR field approval before use per FAR Order 8900.1 and 14 CFR Part 43. Substituting without approval risks airworthiness certification. Logging or testing alone does not satisfy compliance. Temporary substitution is also prohibited without documented authorization. Question 25. Taking into account vibration and stress loads on HVACR components in aircraft, what is a major reason why hermetically sealed compressors are preferred over serviceable ones in many aviation vapor cycle systems? A. They offer lower initial cost and are easier to ship. B. They have integrated mufflers that reduce noise in cabins. C. Their sealed design withstands vibration and requires less maintenance. D. They use more environmentally friendly refrigerants. Answer. Correct answer. C. The sealed design withstands vibration and requires less maintenance. Explanation. Hermetically sealed compressors are robust against continuous vibration and are maintenance-free by design. FAR X and maintenance best practices recommend these for applications where access is limited and failure must be rare. Open or serviceable compressors are more common in ground systems where vibration is less of a concern. Question 26. One might argue that electrical failures in vapor cycle X units are often due to issues unrelated to the HVACR components themselves. Technician Sal finds the unit is intermittently tripping its circuit breaker. What is the first system component he should check? A. The condenser fan motor windings. B. The compressor oil level. C. The expansion valve. D. The ground bonding of the X unit. Answer. Correct answer. D. The ground bonding of the X unit. Explanation. Intermittent breaker trips can be due to ground faults or poor bonding, especially in aircraft where EMI protection and bonding are critical. FAR C43.13 and METIDA 464 stress the importance of grounding for both safety and signal integrity. HVACR components like oil levers or ESVS wouldn't directly affect breaker behavior. Question 27. During performance verification of a newly installed vapor cycle system in a mid-sized jet is near finds the system cools adequately but takes significantly longer than design specs to reach target temperature. The refrigerant charge is correct. What is a likely cause? A. Excessive insulation on suction lines. B. High moisture content in the refrigerant. C. Incorrect airflow balance across the evaporator. D. Oversized expansion valve. Answer. Correct answer. C. Incorrect airflow balance across the evaporator. Explanation: if the airflow across the evaporator is low or uneven, it reduces the rate of heat absorption, causing delayed cooling even with proper charge. HVAC guidance and ASHRAE handbook recommend verifying airflow first before suspecting components. Moisture affects freeze up or pressure, not speed of temperature change. Oversized ESES usually result in control instability, not slow cooling. Question 20. Contrary to popular belief, adding more refrigerant to an underperforming X system will not always improve its performance. Under what condition would additional refrigerant actually worsen system behavior? A. When the evaporator coil is too large. B. When the condenser fan is underperforming. C. When the expansion valve is oversized. D. When the system is operating in a subcooled state. Answer. Correct answer. B. When the condenser fan is underperforming. Explanation: if the condenser is unable to reject heat due to a faulty fan, adding refrigerant raises high side pressure, stressing components and reducing system efficiency. HVAC guidelines and EPA Section 608 caution against adjusting charge without performance data. Subcooled state isn't inherently problematic. Valve sizing doesn't justify overcharging. Question 29. During the process of inspecting the X ducting system in a twin turboprop aircraft, Mr. Holden notices airflow noise near the aft lavatory. The airflow is sufficient and temperature is within limits. What is the most likely issue? A. The duct is rapid through an unpressurized section. B. A damper is vibrating due to resonance. C. The discharge diffuser is undersized for the duct velocity. D. The fan speed controller is malfunctioning. Answer. Correct answer. C. The discharge diffuser is undersized for the duct velocity. Explanation: high duct velocity with an undersized diffuser leads to turbulence and noise, especially at turns or bends. FAR Order 21 standards stress matching duct velocity to diffuser size to reduce noise. Resonance is possible but rare. Fan control would affect volume, not localized noise. Rattling through unpressurized areas wouldn't create airflow noise alone. Question 30. From a practical standpoint, why are aircraft X systems required to maintain a minimum air exchange rate even during low occupancy or standby operations? A. To prevent carbon monoxide buildup from engine bleed. A. B. To maintain FOM mandated oxygen concentration levels. C. To prevent cabin material off-gassing accumulation. D. To keep the aircraft electronics at optimal cooling state. Answer. Correct answer. C. To prevent cabin material off-gassing accumulation. Explanation: aircraft interiors emit volatile organic compounds, VOCs, especially when static. FI C12089 and ASHRAE aircraft ventilation standards require minimum ventilation rates to mitigate health risks from material off-gassing even without passengers. Co-protection is handled by separate filtration. X cooling for electronics is zone-specific, not total air-driven.